Hi, welcome. My name is Terry Frohmiller. I am with VMware. I've been in solution engineering for a long time, but about a little over 10 years with VMware. I'm coming to you from my stand-up desk near beautiful Lodi, California. I want to introduce, so we have 2 sessions in a row coming up. So the first one is, scrolling up here, sorry, is building and managing training data sets for machine learning with Snorkel. And our speaker is Paroma Varma, and she is, I have your name spelled 2 ways, Paroma, sorry. She's a research assistant at Stanford University. She received her PhD from Stanford and her BS in EECS from UC Berkeley. She's a recipient of the National Science Foundation and Stanford Graduate Fellowships. Pause there. And the Arthur M. Hopkins Academic Achievement and Outstanding Course Development and Teaching Award. Wow, we could really get you to a few homes right now for homeschooling.
I know.
We could get you a great gig. So I just want to point out, if you have questions, please post them in the Q&A. I noticed on these sessions, which have all been very great and interactive, is that people are chatting on the chat, just, you know, I'm from Miami or whatever. But if you actually want a question answered, Mandy's going to respond to those and help kind of feed them over to Paroma. So please use the Q&A portion, and we'll let Paroma take it away.
Awesome. Thank you so much for that introduction. Let's see. Can you all see my screen? Okay.
Yeah.
Awesome. I'll go ahead and get started. Hi, I'm Paroma. As Terry said, I just got my PhD from Stanford, and I'll be talking about Snorkel, which is one of the projects I worked on while I was there, which is focused around programmatically labeling training data. So, you know, to start off and set some context, machine learning is truly everywhere now. It's being used across a variety of use cases, from images, text, natural language processing, chatbots, self-driving cars, and just so much more. And one of the reasons that machine learning has become so successful recently is, you know, a combination of a few things. Number one, there has been a lot of research done for the state-of-the-art models, some of which have been able to achieve, you know, human or better than human performance. And it's been easier than ever for others to be able to use these models because of libraries like PyTorch, TensorFlow, Keras, which allow users to kind of write one line of code, like, you know, import BERT classifier from PyTorch, and be able to get access to the latest and greatest that's been, you know, maybe been published like a day or 2 days ago. Something similar has also happened with hardware, where the cloud providers have made it really easy, you know, well, I guess easy in terms of number of clicks you have to do, but not so easy maybe in terms of the pricing. But, you know, if you want to use the best and the fastest GPU, you can just few clicks of a button and you have a machine up and running. So what's really happened here to help machine learning is that the state-of-the-art models and hardware have really become commodities for people to use. What hasn't really seen the same type of success and ease of use is the training data. The training data still has to be customized and, you know, specially labeled for every single machine learning task that people are trying to use. And other than the benchmark data sets that are available, there's no really easy way to say, hey, I want to apply machine learning to my own task. Can I just import the training data that I need? And this is exactly the problem that Snorkel is trying to solve. What we noticed, you know, while we were kind of working with people trying to use machine learning across industry, Stanford hospitals, the VA hospital here at Palo Alto, was that engineers were spending a lot of time shaping their training data instead of spending time on other aspects of their machine learning pipeline. And what does shaping training data mean? This can include anything and everything that has to do with data the way we see it. You know, there's labeling the data, there's collecting the data, there's augmenting your existing training data set to increase its size. It's reweighting and resampling the data so that your machine learning model actually gains performance on the subsets of the data that you care about. So with Snorkel, our key idea is that we want to be able to use noisier sources of supervision and signal to be able to rapidly and efficiently generate training data sets. So during this talk, I'll focus on one aspect of this, which is the labeling aspect, but I'll leave time for questions if people want to learn more about the augmenting and reweighting aspect as well. So before I jump into the details here, a big thank you to everyone who's on the Snorkel team, as well as our users and sponsors, without whom we wouldn't have been able to get so far in building Snorkel and the open source software. So let's start off with an example to kind of root this entire Snorkel pipeline in. Let's say we want to build a machine learning algorithm that helps us classify emails as being spam or not. So, let's say we have a bunch of emails and now we want to feed it into this machine learning model, which can then help us predict whether a particular email is spam. The first step before we even, kind of start designing our machine learning model is the data that we're working with. If we have this training data available to us, we need it to be labeled. We need to know which emails are spam, which emails are not spam. And this might, initially be some user label data. Some of it might have to be something that we go through manually as machine learning engineers and, look for specific patterns to see, hey, is this a spam email or not? And you can kind of see how as the number of emails increases, as the types of emails increases, this manual labeling process can become really hard to scale. So what we did was we kind of started thinking about, when people are hand labeling their data, what are they actually thinking in order to be able to assign these labels? So one really easy thing that people do is they look for patterns and heuristics in their data to be able to assign a label to them. One really easy example that we have on the slide here is looking at, let's say someone is asking for money. If they say, hey, I'm royalty, I need money, you kind of think this is probably a spam email. But in the kind of same vein, it's not like just looking for money is going to be a very high accuracy heuristic just because, maybe your relative is giving you money for your birthday. But the underlying kind of learning that we had here was that there is a possibility of using some higher level patterns and heuristics to be able to label the training data. So what we did was exactly that. We created these rules that are, say, something like, hey, if the word need money is in an email, it's probably spam. If it's offering some like ridiculous amount of discount on some, I don't know, computer or software program, it's probably spam. If it has a relative's name in it, it's probably not spam. The key here, again, is that these rules can be inaccurate. And the algorithm behind the Snorkel framework does exactly what we need it to do, which is take these imperfect rules and combine them in an optimal manner. And I'll go into details of that in a little bit. So what we do with these rules is we actually codify them in a language, in this case, Python. And what this does is it makes it really easy for users to be able to kind of codify these rules and heuristics that they have in their mind to label training data. And it also becomes really efficient. Say you have 4 or 5 of these rules. It doesn't matter if you're applying it to, say, like 5 data points or if you're applying it to kind of 1,000,000 data points. The amount of work that the user has to do in terms of writing the rule remains the same. So jumping into the overall Snorkel pipeline right away, we kind of break it into 3 main steps. So first, we have the input, which are these labeling functions, which are codified rules and heuristics that the user writes. The next step is the label model. This is the core algorithm behind Snorkel. It's a generative model based on a factor graph, which takes as input these noisy rules and then combines their outputs optimally in order to assign probabilistic labels to the training data. This training data, now that it has labels from our label model, can now be used to train any downstream machine learning model. Again, going back to what I mentioned earlier, if you want to import one of the latest and greatest models, we can now train it with these training labels that we've just created by writing a few rules. The efficiency in this pipeline really comes from the fact that the users interact with machine learning pipelines via these labeling functions and not via hand-labeled training data. So what I'll do next is just step through each of these stages at sort of a high level and then pause for questions for if anyone has any. So step 1, which is writing the labeling functions, the main kind of role of the user in this pipeline. So we have two tasks here. I'll go through them one by one. So let's say, one of the tasks that we're focusing on is a classification task, and we're trying to see if a particular chemical highlighted in a sentence causes a particular disease highlighted in the same sentence. So if we're trying to write rules around this, we might look for certain words that, that signal towards causality or non-causality. Like we can look for words like because, due to, or words like not cause. So we do exactly that. We write these two labeling functions in Python looking for these specific patterns. And these are our labeling functions in this case. We can do something similar with non-text tasks as well. So in this case, we have an image and we're trying to figure out whether there's a person riding a bike or not. What we can do in this case is run our image through one of the existing object detection pipelines, find bounding boxes for the objects that are in this image currently, and then write rules over their relative positions and sizes. So one really easy rule would be if a person is above a bike, that person is probably riding the bike, which is exactly what we do here. One last thing that I wanted to highlight in terms of writing labeling functions is if you notice here, we actually return a label if, say, there's a specific phrase in the sentence we're looking at. But if that phrase doesn't appear, we don't say that it's false. What we actually do is we abstain. And this essentially means that the set of labeling functions we have don't necessarily have to label every single data point. They can only label the ones that they're confident about. Going back to the spam example that we had, with this ability to abstain, what we would do is say, hey, if the word like I need money is in the email, then it's probably spam. But if the word I need money is not in the email, we don't know. So we'll just abstain from voting. The second step, again, is the core of the Snorkel pipeline, which is the machine learning model that actually combines these labeling functions optimally. So what we do here is we look at all the rules that the users have written, and we look at the labels that they assign to all the data points. And we actually are able to estimate the accuracies of these different rules by looking at the conflicts and overlaps between them. The really important point and kind of the really cool aspect of this algorithm as a whole is the fact that you don't need any ground truth label data to be able to kind of use this algorithm. So what this means is, it's not like you have to label 100 data points, write some rules, and then run this algorithm. Even if you don't have any data points with ground truth labels, the algorithm is actually able to just learn how accurate these rules are using the agreements and disagreements between them. I think one example that I like to give is kind of like, hey, if we assume like, most people in a room are truthful, and let's say we start polling them, one easy way of trying to figure out whether people are, reliable or not is seeing how much they tend to agree with others. Versus if there's one person in the room who's just randomly shouting out answers, you would probably not trust them as much. So that's kind of a toy example of, the math behind this algorithm itself. Another thing that we do is we actually also look at the correlations between these labeling functions. I think one thing that we noticed was fairly common when we were working with users was there were multiple users writing these rules, and sometimes they relied on the same patterns. And we didn't want users to have to go through their list of labeling functions to see, which ones might be similar and remove them. So just as part of the Snorkel core algorithm, we also include a way of learning, which labeling functions are dependent, which ones might be correlated. But again, we do this just using, the structure of the code or the overlaps between the labels themselves. There's no need for any ground truth label data. Finally, after we run the Snorkel algorithm, we'll have probabilistic training labels for all the training data that we're dealing with. And we can now use it to train any, state-of-the-art machine learning model. One of the questions that we often get is why do we even need to train an end machine learning model, right? Why don't we just stop at, we have a machine learning model, which is this label model. It's given us probabilistic labels, which is exactly what we need. So why are we going this extra step? I think the main reason we do this is the labeling functions can abstain. So, even if you write, let's say 10 or 15 labeling functions, there's no guarantee that you're actually labeling every single data point. So the end machine learning model is actually able to generalize beyond what the labeling functions capture and assign final predictions to every single data point. I think another reason that training a machine learning model can really be helpful is the fact that you have these labeling functions that you're writing, but they're focused on very specific aspects of the data. Going back to, say, the email spam example, we're only looking for certain words or phrases versus, let's say you train like a BERT model or an LSTM model. Those models can take in so much more and account for so many more features of the data, like the context, the length of the email, and things that we might not have accounted for in the labeling functions themselves. So, by creating this label model, we don't want to discount the fact that these end machine learning and really powerful state-of-the-art models are really meant to give you that performance boost. That's great. Your Snorkel pipeline, we created this, we worked with a few users, and we were feeling really great about ourselves. But I think one question that we hadn't answered yet was how easy it is for people to use Snorkel if they're not working with us closely. So we actually held a workshop to test this exact hypothesis. We worked with a set of biomedical experts, so they weren't necessarily computer scientists or coders, but they really knew about the tasks that they were working on. So what we did was we kind of split them into two groups. On the first day, one group spent time just hand labeling data points. So they had, I think, 4 or 5 hours, and all they did was just hand label data points and then train a machine learning model. And what we saw was that kind of the average score of the trained model with hand labeled data points was around 24.6 F1 points. What we did the next day with the same group was we actually trained them on how to use Snorkel for the first few hours and then had them write rules in the Snorkel framework. And what we saw was, even though they were spending the same amount of time kind of labeling their data, they were able to get almost 25 points more than they did last time. And the main reason for this is, again, when you're hand labeling data, you're kind of going one data point at a time. So it's not scaling very well. But with writing rules in Snorkel, you're able to write maybe 5 rules or 6 rules, but now you're able to apply it to all the data that you have available. So in this case, even though they only hand labeled around 2,000 data points, they were able to write rules to label 20,000 data points. And this significant increase in the amount of training data they were using is what really led to the improved performance. One interesting fact from that workshop was actually the person who got the 3rd highest score was someone who didn't know machine learning at all. So another thing that we learned from this workshop is, while trying to build this platform for people to label machine learning and make machine learning more accessible, we also had to keep in mind that we want to make it user-friendly enough that even people who aren't ML researchers, even people who aren't data scientists can still feel comfortable enough writing rules within Snorkel. So what I'm going to do is I'll just pause here if there were any questions that came up, just because now I'm done kind of talking about the Snorkel basic pipeline, and I'll probably jump into some of the advanced features that we've worked on since then. I actually see a question in Q&A, and the question was, can you please clarify without ground truth to compare, how do we know if the model predictions are correct? So this is definitely a great question. We still require ground truth data for the test set and the validation set, just as you would for any machine learning model. The part that we don't require any ground truth labels for is the training data itself. So even though we don't have ground truth for training data, the way we do all our evaluations is we actually evaluate the end machine learning model that's trained on labels from Snorkel and then see how it performs. So continuing on, we had this idea of labeling functions. And again, after the workshop, something we were really interested in is how can we make Snorkel even easier to use for people who aren't necessarily data scientists or who aren't necessarily, people who are very comfortable writing Python or code even. So kind of like what people did in computer science, kind of going up the stack and making languages easier and easier to use at a higher level of abstraction. We tried something similar with Snorkel as well. We already had made the jump from requiring individual labels for all the data points to being able to write labeling functions that automatically assign labels. And, then we kind of kept climbing up the stack, and we were able to look at how people can maybe write natural language explanations instead of writing labeling functions. Maybe people can, give some pointers, and we can actually generate these labeling functions automatically based on some templates. So I'll just go through a few examples of those things that we did. So the first one that we tried, again, this is probably one of my favorite projects from kind of the Snorkel set of projects. We were able to take natural language explanations that people would write about why they labeled a particular data point the way they did, and automatically convert it to labeling functions, and then go through the normal Snorkel pipeline. But what this really did was, it really lowered the barrier to who could be the types of users who are interacting with Snorkel. They didn't need to know computer science. All they needed to know was the task that was at hand. Let's say, going back to this, does this chemical cause a disease in a particular sentence? And they can just write explanations like they would as if they're explaining it to someone. So they can say something as easy as, yes, this is a true example because the word due to appears between the chemical and the disease name. And we had a semantic parser that was able to generate labeling functions from a few of these examples and get training labels, which were then able to train an end machine learning model. Just a quantitative analysis back related to this particular project, we actually only collected 30 explanations, which took, less than 30 minutes to write. And they were equivalent to the quality of having 600 hand-labeled examples. Again, this goes back to the fact that Snorkel really helps us scale the amount of training data we're labeling really easily, but also just speaks to, how easy it is now for users to interact with this platform. Another thing that we saw users were struggling with a little bit is whenever they were dealing with labeling functions that had numerical thresholds or any number guessing associated with it, they used to write a bunch of these labeling functions, manually iterate of like, oh, what if I delete this one? What if I add this one? What if I increase the number that I have in my labeling function by 0.5, by 0.25? So this was kind of becoming as painstaking, if not more, than manually labeling your data. So this is something that we wanted to address. And what we did was we actually created a system that's able to generate these labeling functions automatically. Of course, there's no free lunch, so there is a catch here. We kind of shifted away from requiring no ground truth labeled data to requiring a small amount, maybe like 10 to 50 labeled examples. So we're actually able to generate these labeling functions themselves. But what we saw was, especially for numerical based tasks, these automatically generated labeling functions were usually much lower in number and also performed much better than, a set of labeling functions that users had written, just because a computer and a system is able to do the guesswork in terms of thresholds and numbers much easier than a human. We also applied it to various tasks from radiology to natural images and videos, and saw kind of similar gains in performance. And that brings me to the end of the talk. So really happy to take questions. We have our open source software tutorials, introductions, and blogs related to it at snorkel.org, which is our website. As I mentioned way during the beginning of my talk, I only focused on the labeling function component of Snorkel, but we also have similar abstractions related to how people can augment their training data and how they can specify subsets of the data that they care about high performance on using transformation functions and slicing functions. Again, more information is on the website, but would love to get any questions and answer them right now.
Okay, I'm gonna see anything from you, Mandy. Let's double check in here. Not seeing.
There are no new questions at this time.
Okay.
All right. Awesome. Thank you so much. Really enjoyed this experience, even though it was remote. I think thank you to everyone who set this up and made it so easy to be a part of this.
Yeah, it was great. Thank you very much, Paroma. It's pretty incredible and exciting what can be done, right, with machine learning and data. And I'm a big fan as a kid of the Jetsons. Anybody, if you go back to then. And what's interesting is how technology, right, keeps changing and growing, and some of the incredible things we can do. And I always go back to the cartoon where they're holding little Elroy up to the video screen so the doctor can look down his throat. How many decades ago was that? And that's what we're doing today.
Yeah,
so,
yeah, definitely.
And I actually worked for a company that collected data. We created a system called Patient Tracking System, PTS, to try, and this, we're talking early to mid 90s. We were trying to collect data manually to figure out outcomes for patients who had certain criteria. And again, it was pretty manual. It was really fun to see the outcome, but man, the work, right? So anyway, this is exciting. So thank you very much for your time and for participating. I thought it was great.
Thank you so much.
I think what we'll do here is we'll go ahead and introduce our next speaker. So, so our next speaker is Sonia Rohan, and the presentation is DevSecOps. Oh, you know what? Sorry, guys. I just want to make sure that we don't have attendees switching. Oh, Namita has a hand raised. I don't know what that means, but did you want to put something in the chat or Q&A? I'm wondering if people are joining halfway through to pick up if they're interested in security automation. Should we give it a couple minutes? What do you guys think? Should we vote with our hands? I don't want to leave anyone out, so. Any thoughts? Okay, let's see how the attendee list is looking. It's looking the same. Oh, Jody. Okay, a couple minutes. And then anyone else raise a hand? Okay, yeah, let's wait. Anita has a hand raised. I don't believe we can unmute, but if someone has a question, because their hand's up, we can put it in chat or Q&A is fine. There's enough of us monitoring so we can catch it.
Hey, Terry, actually, I can't allow Anita to talk if that's what we want to do.
Correct. No, I said let's put it in the chat or in the Q&A. Yeah.
Perfect.
I said I don't think we can allow, the audio. Plus, this is recorded, so if anyone else has any entertaining info besides the Jetsons cartoon. Oh, Anita. Okay, gotcha. Let's wait. Excellent. Okay, so we just have another minute or two. I'm pretty excited about this morning's keynote, by the way, and I'm excited about this afternoon's keynote. I've had the privilege of going to Women Transforming Technology in Palo Alto once before. It's actually pretty hard to get a ticket. I'm hoping in the future when we can leave our homes and there's more attendees in person, we can actually expand to a bigger venue and have more people attend, because it's a pretty incredible session, and the content and the speakers and the keynotes are all really fun. And when you're there in person, I'm not trying to make anybody feel bad, but there's other things outside of the sessions that you can get done, like get your photo taken, things like that. So. Okay, well, I'll tell you what, it's right at 1:30 Pacific time, and Sonia is in the east, so we should get her going. Okay, so our next presenter is on DevSecOps, security automation in large code base, and the presenter is Sonia Rohan, and she is a VMware software developer in end-user computing. She works with the core platform team responsible for development of security and privacy features for Workspace ONE, which is pretty incredible in today's environment with, I know at least at VMware and some of our solutions, we have tens of thousands, hundreds of thousands more, right? End user computing users than we did probably 3 months ago. So, and as we know, security is important. So Sonia graduated with a master's in cybersecurity, which I think is super cool, from Georgia Tech in 2017. If I could go back to school, I think I'd do that. I'll let you go now, Sonia. Take it away.
All right, thanks, Terry. I'll share my screen now. All right, can you see my screen?
Yes, you are.
Yes.
Thank you. Thanks, Terry. All right, thanks for that introduction, Terry. I've been working with VMware for about 2 years now, and I work in R&D out of the trade floor in Atlanta office. Some of you might know me, some won't, but I just wanted to say this up front. Feel free to reach out to me after the session to discuss any thoughts, ideas, or suggestions around this topic. And you can see my contact details are there on the bottom right. And I have a disclaimer. I have a lot of useful content on the deck that I possibly cannot discuss in depth in this session given the time constraint. So pardon me if I end up going too fast, and I'm sure we can probably share this later with the group. All right. So I just wanted to start my talk today by spending a little time talking about DevOps. Now, I hope everybody here knows about it and possibly are adopting best practices. So this is true all over, by the way. DevOps has immensely gained traction in the past few years, and many organizations are now harnessing close synergies between dev and operation. But how do they do that? So by adopting principles of collaborative development, shorter feedback cycles, continuous integration and delivery, companies are able to achieve better time to market, more customer satisfaction, innovation at a faster pace. So as you can see on the left side of this left half of the slide, the trends are also showing the same things, that these numbers are only expected to rise more and more over the years. Moving on. For the longest time, security had been a sort of afterthought, in the sense that developers would write code and then they would just tend to forget about it until some major issue or vulnerability would show up, maybe from outside, or more commonly, it's caught in a relatively later phase of development. Now that calls for rework, which hurts production timelines, right? So companies which are leading these DevOps initiatives understand this, the need to bake security into the picture right from the start and to be able to achieve full potential. Hence, they are adopting active strategies to get security in the loop from the start. But despite that, there is still a big gap in security expertise within the DevOps team. Okay, this gap can be addressed by DevSecOps. It aims to remove the barrier by giving security teams full transparency into production cycles, shifting security leftward, as I mentioned before, much closer to the development and design parts. Also automating and integrating security tools into pipelines, and increasing the deployment frequency of secure quality code by releasing patches quickly and giving developers confidence to create production-ready code quickly. So to be able to successfully implement these ideologies, that requires changes in both mindset as well as processes. So the idea is to embed controls in various aspects of SDLC, from deployment pipelines to third-party integrations to defect monitoring, as well as bringing an overall cultural change. All right. The first and most important category to implement security as code is about building security into your existing DevOps tools. Now you do that by mapping out how changes to code and infrastructures are made and finding places to add those security checks without obviously introducing unnecessary cost or delay. So security as code uses the CD pipeline as its backbone. Let's look at it like step by step and go more into detail about this. So starting with the first stage, which is of pre-commit. Now on this slide, you'll see that there are some questions that are helpful when doing threat modeling and risk assessment. These questions are important in microservices environment as well, in which teams are generally pushing for flexibility to use the right tool for the job. However, they can't necessarily control who calls their services and what those callers expect, right? So answering these questions will help you understand the need to look more closely at your design or technology, Or even when should you review and verify trust assumptions? The key to threat modeling is recognizing this, because design, coding, and development are done continuously, right, in a tight iterative loop. That means that you can and you must make threat modeling efficient, pragmatic, and fast. Developers can also take advantage of built-in checkers to their IDs to catch security problems and common coding mistakes. One more important thing is peer review. The idea of peer review is simple, that developers should keep a check on code quality themselves. They should check themselves and also just their peer. If done right, this can be an effective way of stopping unwanted security degradation and insider threats, just because of the transparency and accountability that it brings along. Now, high-risk code pieces such as your authentication mechanisms, access control, output sanitization, crypto, these require extra attention to be able to work correctly, including under error conditions and boundary cases. In a microservices-based system, sometimes identifying these high-risk pieces is kind of tricky. And this can be done by mapping call sequences. So what is call sequence is simple. It's like if a service is being called by a lot more other services, that is going to be marked as a high risk. And basically, it's a way to track how much information flow is happening between services. Now, encouraging developers to use defensive coding practices like parameter validation will go a long way to improve the runtime reliability of the system. Obviously, like big no-no things like hard coding credentials or attempts to create your own crypto can be caught easily in this step as well. So after commit is in, there's a bunch of tools such as SAST, SCA, security unit test, and build compile checks, which come into picture. Now these are useful to provide gatekeeping. Any build which fails these should not be upgraded to any higher environment. Static code analysis is a type of security testing that analyzes your source code, including bytecode and binary, but it's not executing code, right? So these code can find subtle mistakes that reviewers will sometimes miss. It's quite essential to integrate an automated static analysis into your SDLC to continuously identify defects and potential vulnerabilities. There are proven SaaS tools available today for popular languages like Java, C++, C#, as well as common frameworks such as Spring, Struts, and .NET. To make sure that the feedback loops are effective, it's important to tune these tools to minimize false positives and provide developers with clear, actionable feedback. Moving on, like SAST, software composition analysis, that also analyzes source code. These tools identify open source components in your application and any associated vulnerabilities that may have been reported against them. More often than not, in just having SaaS tools alone cannot identify these vulnerabilities. So it's important to incorporate SCA for a secure DevOps pipeline. So for example, in March of 2017, it was reported that certain versions of the Apache Struts framework were vulnerable to remote code execution attacks. So if you were using a vulnerable version of Struts, the recommended remediation was to upgrade. If you were using SC at that time, you could have easily known which of your applications are using that particular library. And then basically it makes it easier for you to upgrade. For security related code and framework code, we should also convince our developers to step off the happy path and actually write good unit and integration tests around, and especially outside boundary conditions. We need to test exception handling and write negative tests that should never pass unless there's something wrong in the system. So for example, tests which prove that unauthenticated users can't access admin functionalities, or that a user can't see information for a different account, things like that. If these tests fail, something is broken and we want to learn about it as early as possible, right? Again, InfoSec needs their own view into our pipeline and into the system to track vulnerabilities, to assess risk and understand trends. They need metrics for compliance and risk management purposes to understand what to prioritize during their training efforts and to assess their security program. So collecting data on vulnerabilities lets you ask some important questions, like how many vulnerabilities have you found, how were they found, what tools were used to find them, and what are giving the best returns. Things like, is it getting better or worse over time? So trends. You can get this information by feeding the security testing results from your pipeline into a vulnerability manager, such as CodeDX or ThreatFix. All right. Third step, dynamic analysis security testing, or DAST, are useful for testing web and mobile applications. But they don't always play nicely in the CI/CD pipeline that we are discussing, right? Because most DAST tools are designed to be run by security analysts or pen testers, not in a Jenkins or Bamboo kind of engine. There are also tools like OWASP has a ZAP, which automatically scan the web app, finding common vulnerabilities. And you can do that by either running it in command line in headless mode, or their APIs, or just a wrapper, such as Jenkins, I think, has a plugin for ZAP. Or you could be using a high-level test framework like BDD security as well. So first testing is generally not predictable, or it's not repeatable. So the nature is to try random things and see what happens. The system might crash, or some kind of exception might occur that can leave that system in an undefined state. Result of this fuzzing can also be difficult to assess and might need a manual reviewer, right, to identify problems and recognize when those problems have the same cause. So good fuzzing will take hours or days to complete, and takes a lot of CPU cycle, which makes it kind of difficult to fit into the time box of how CD works. Having said that, there are some newer fuzzing tools that can be adapted to run in CD. They let you see test values so that you can create repeatable tests, set time boxes on runs, and detect duplicate errors, write scripts to automatically restore or set up state in case the system crashes. But you might still find that fuzz testing is best done out of band of this pipeline. One more thing I want to add is the real value in these tests is not just the bugs that they find. Of course, that is the one more important thing, but it's also the information that these bugs are revealing. And these give you cue to look deep enough and find what is the main cause and how did that get there in the first place. That similar principle applies to bug bounties as well. So if we enlist the community of security researchers to find bugs in your software, obviously we get access to creativity and skills that companies wouldn't find otherwise. But more importantly, they provide them with information on where they need to improve their design or coding or review and even configuration management. Another kind of runtime defense technology is RASP, which uses runtime instrumentation to catch security problems as they occur. Now, like application firewalls, RASP can automatically identify and block attacks, but unlike firewalls, it is not a perimeter-based defense. So the RASP instruments run the application and can identify at the point of execution, like attacks or block attacks. Now, instead of creating an abstract model of the code, like how static analysis tools do, RASP have the visibility into the code and runtime context. And so they use state analysis, data flow and control flow analysis techniques. So directly examining data variables, statements, this means that RASP tools have much lower false rate compared to firewalls. There are only a small number of RASP solutions available, and mostly they are limited to applications that run in Java, JVM, or .NET. Although I think there is support for other languages coming up pretty soon too. All right, so to demonstrate some of these concepts we just went over, let's look at a case study. So this is about Tyro Payments, which was a payments processing startup from Australia, which is now a full-blown fintech. So they wanted to incorporate security consideration early into their design phase. If there were any threats, they wanted that these are documented so they would not be forgotten, and any future developer that ends up working on it already has access to that information. So when they started, the expectation was that during a threat modeling session, they would draw the architecture of on the whiteboard, and everyone would kind of identify the entry points and dependencies. And then they would also give a dread score, which was basically a way for them to identify potential threats and a rating of sorts. After that session, whatever information was captured would be recorded in their threat model document. And teams were asked to review that threat model document every time any new feature was planned to ensure that it was up to date and everybody had knowledge. The reality, though, was a little different. It was kind of difficult to identify entry points into a system that doesn't even exist. Also, legacy code and systems are pretty big. So to know where there are a lot of unknowns and all the entry points are not easy to identify. Red score was a disaster to get consensus on. Also, sometimes attack vectors were kind of muddy because of the location of the piece. The idea of documenting everything soon saw downfall as it was hard to maintain. And just the time invested in keeping things up to date was increasing more and more. And so it didn't turn out to be how it should have been. So they figured that they needed to move to an automation step, and they followed this 3-step policy. First change was that they generated the list of entry points from the source code. So this was done via code executed by Test framework that produced a table that could be directly copied into the threat model. The second change was that to record that threat model outcome in code. That means the information which is related to threat model is kept right next to the code. It gives more visibility for those looking at the code or modifying it. This was done by using assets and annotation to generate threat models output, but this was not welcome as this was changing the size of the class size and just the file size, right? So to overcome this, they started to create threat models using unit tests. They were able to create new tests based on finding from penetration testing as well. So this means that they were able to identify all potential security issues earlier, and they were able to address them much before they went to production. All right. So next up, creating a culture of open source is instrumental to meet strategic goals and business requirements these days, right? So with the shift to DevOps, a lot of companies such as Capital One, ING are moving to open source first policy because they realize that the bug resolution is faster sometimes compared to proprietary software. Scanning for known vulnerabilities is easy and more transparent. There's also evidence that the level of open source adoption does correlate to DevOps success in general, but this comes with a bunch of interesting problems. Keeping an inventory of what open source is being used is a big problem sometimes. Like a lot of companies think they don't use any open source or dependency, but that's not true. A lot of their codes are libraries, which people just forget, like is a third party, sometimes just something as basic as a jQuery. Also, a lot of time they rely on one tool, which works well with one framework maybe, but it's not as good for another one. So for example, dependency check from OWASP, the way that they check for vulnerabilities is different in .NET Core and ASP.NET. So if you run it in a .NET Core app, it will say that there is no dependency. But if you are even using some bunch of NuGet packages or jQuery, then there's probably some dependency there which is not being captured. Some advanced products tend to check more than one database for vulnerabilities, and that's good, just because not all vulnerabilities are reported in the same place, right? Which kind of leads to the second interesting open source issue. So security researchers or even just open source contributors, they find a bug and let's say it's reported. Now what happens is mostly these fixes will be first committed, and typically after a day or two, it will be released as a patch, right? So the problem with this can be that there could be attackers out there who are ready to reverse engineer these commits to identify the piece. Now, since these patches are mostly straightforward, this gives a kind of nice gap for them to get to exploiting until it's being released. So we also know that not everybody moves to the latest patch, right? Which kind of relates back to the first thing that many times they're not even aware what version they're using and whether they're using that package at all or not. Another way that the attack vector is different for open source is that more so often package managers like Homebrew, NPM, or NuGet are being used in supply chain attacks. That means they're distributing malicious code. So now instead of just waiting for a 0-day to happen, they're also able to create their own. And sometimes it can be simple as uploading a crypto miner also. So next, yeah. So the idea of logging security as a part of your day-to-day ticketing is also to integrate it seamlessly with other product requirements and bugs. So there are tools like Veracode which provide such integrations. So this way, both product bugs as well as security issues can be made part of the sprints, agile sprints easily. On top of that, there should also be a security sprint just to work on security features, deaths, and residual risk acceptance. Excuse me. Product managers, security team, developers, all of them should sit together to write these security stories, such as the one in the one mentioned in this slide. So you can clearly see there's backlog task along with the CWD ID. So having common source repositories and artifactories allows us to maintain the most updated version. So making this problem of upgrade easier. If you look at the example on this slide, this gives a quite clear picture of what is the expectation from that story, what are the best practices for that remediation, also just the CWE and CVE for context, as most of the times, like if these are going to be in the top 10 or top known OWASP top 10, then you would probably already have a remediation step for that, right? Another classic example of innovation in security management was Netflix chaos engineering. Now, I don't know if everybody knows about it, but Netflix, when they moved to AWS, instead of holding their own physical infrastructure, wanted to be sure that if there was a loss of, say, Amazon instance, that wouldn't affect the streaming experience at all. So to do that, they created Chaos Monkey. Later, they also added additional features like failure injection mode that would allow testing of a more complete suite of failure states. And thus, they were able to build resilience into it. What the principle of chaos engineering is as follows. You start first by forming a hypothesis about how a system should behave when something goes wrong. Then you design the smallest possible experiment to test that in your system. And finally, you will measure the impact of the failure at each step, looking for signs of success or failure. When that experiment is over, you will have a better understanding of how your system is behaving in real world, right? Okay, a question that might come up here is, why would they break things on purpose? So it's helpful to kind of think of an example of a vaccine or a flu shot here, where you would essentially inject yourself with a small amount of potentially harmful body in order to prevent an illness, right? So chaos engineering is a kind of tool which builds that kind of immunity in technical system by injecting small harms and sometimes even big harms like latency, CPU failure, or like network black holes in order to find and mitigate potential weaknesses. These experiments have been added to benefit the teams while building muscle memory in order to they're able to resolve things faster. By breaking things on purpose, they surface unknown issues that could impact their systems and customers in the future. Another case study, which is pretty close to my work, is about VMware Workspace ONE. That's where I work currently. So since about the end of 2018 and 2019, we are on a tight modernization effort, which means to divide our large code base into smaller, specialized microservices and service-to-service communication. Now that also means we need faster pipelines, build stability, moving towards blue-green deployments, etc. So let's look into some of the practices that were adopted. So we now have like separate Bamboo plans that upload build artifacts to Veracode on a bi-weekly basis. Jira tickets are created as a result of that scan. Tickets are assigned to team via Git blame. There's also cross-organization code reviews, design reviews. We have dedicated resources for thread modeling. We have static code analysis in place. We also have integration and unit tests covering authorization and authentication for our APIs. There's vulnerability management, and all app check is used to scan third-party packages and open source packages. There's also obviously challenges that come along. So one bigger challenge is that our server-side code is large and everything takes long, including scan and build pipeline and stuff like that. So we have to constantly try to reduce that. And Veracode or even other SEA tools, they need proper tuning to avoid flooding the system with false positive. And there are also some gaps in automated testing. So these were the challenges that we identified while trying to up our game in security, basically. Some key enablers for us were that there was more involvement of security experts in everyday development by just bridging that gap. And dev-informed pen testing, modernization of production security testing. So next thing, So finally, let's just look at how people and teams fit into all of this, right? So as was the case with DevOps, DevSecOps also involves a major change in mindset. So people become the crux of this transformation, and security has to be integrated in every discussion. Now, on the flip side, if this transformation does not focus on this aspect enough, people can become the bottleneck. So some of the common concerns that pop up with this discussion are, will I have to hire developers with security expertise? Now, since developers with this expertise and even the other way around are high demand right now, ideal thing would be to leverage your existing dev and security knowledge to turn into automated secure controls. So additionally, upskilling existing talent through cross-training is also another viable option, right? Next thing, won't DevSecOps slow down my pipeline? On the contrary, if it is adopted correctly, over time, it improves your code quality and it should increase efficiency. Don't devs and security teams have opposing ideologies? While it's true that dev and ops is a more natural collaboration, but if you think about it, all the three teams share that same end goal of delivering good, robust, secure code. So contrary to the question, if it helps when development with it helps that development with last minute rework. If security is already involved, they have more transparency. So I would say it's more like a win-win situation. And just to summarize before going on to questions, DevSecOps merely just built on top of the existing DevOps practices. So it aims at building intelligent autonomous systems that are able to identify, that track security loopholes across your pipelines and software supply chain. All right, thanks for being so patient. And now I can take any questions.
Thank you, Sonia. Terry's coming on. Let me just check with the rest of our panelists. Oh, sorry, feedback there. See if we have any questions out there. We only have about maybe a minute or two.
No questions at this time.
Whoa. I do see a
Sorry,
question. Oh, okay. This
can
is
you
more like
repeat? Oh, I see a question.
Right now, the question is a comment, which says, great presentation. So,
thank you.
Okay, I think we might have lost her. Technical difficulties, hopefully not a security breach. Thank you, Sonia. That was great and fascinating. And I think it just reminds us all that goes into security, right? And that it's a constant battle and a lot of work. So thank you for putting that together and spending the time on it. I'll just remind the attendees before we wrap up that we have some great afternoon sessions, and then the closing keynote at 4 p.m. Pacific, if that's not too late for you, with actress and activist and producer Laura Dern, is live only. There's no recording. The remainder of the sessions outside of the keynotes, I believe, will be recorded and shared if you registered. So if no other questions, I'm just going to double check that. Will the slides be available? Can someone answer that? Will the slides be available? Anyone? I don't know if it's based on the presenter decision of making them public. Then we can ask Sanya. So we will find out and get back to you. You will get a link to the recordings, and if for those who are sharing presentations, those will be also on the same site. Hopefully that helps. Can you answer that? Okay. All right. Thanks, everyone. If you have any questions, feel free to follow up. You can connect on LinkedIn, and we appreciate you attending, and have a great rest of your day, and stay safe and healthy.